I'm James Sykes, CEO of Baselode Energy. I'd like to explain Baselode Energy to you as potential investors. Just the uranium exploration concept that we have, that we started about 3-4 years ago. It's a very unique concept, and I think it has already proven very successful. We have a drill program. We have an exploration drill program that has just started, and hopefully some of our targets are as compelling as they seem to be. But again, I'd like to introduce you to Baselode Energy, how we started, who we are, and where we are today. The biggest takeaway, I guess, is the Athabasca 2.0 strategy. We're looking for high-grade uranium in the Athabasca Basin area that is near surface and open pittable. Something that is outside of the sandstone basin itself, because there's water issues with that. And in September 2021, in our first drill program, we discovered what we call ACKIO. That's the name of the discovery. It is high-grade uranium in near surface, about 25 meters beneath the surface. If anybody knows hockey, well, that's the width of a hockey rink, not the length, but it's the width of a hockey rink from surface. So it's not that deep. Pretty accessible uranium. Very cool. Since last year, we completed a 7,500 meter drill program. Overall, we've completed about 32,000 meters into ACKIO since its discovery. NI 43-101 resources pending. Hopefully by the end of this year, we're trying to bring it into indicated right off the bat instead of inferred. As it stands now, ACKIO has 2 zones of near surface basement hosted high-grade uranium. Again, mineralization as shallow as 25 meters and 32 meters beneath the surface, both of those zones. So very encouraging, very shallow. There's not a lot of uranium deposits in the world with that immediate accessibility, and that has a very good momentum behind it when we start looking at things like OPEX and CAPEX. Those are still beyond baseload at this point in time, but that is something that we can certainly discuss. Like to, we're very well funded, $20 million in the bank that will see us through this year. Exploration that we have planned for this year, plus keep the lights on for many years. We do keep our capital very low, like most into the ground, which is how you make discoveries. Myself, if people aren't familiar with the uranium space, I've been in the industry since 2006. I have about 550 million pounds of uranium discovery to my name. That's directly and indirectly. When I started out in 2006, I started with Denison Mines. I was part of the team that prioritized what became the Phoenix and the Griffin discoveries. In particular, for Griffin, I was relogging historic drill core, and during one of those summers, I'd gone to the Millennium deposit and saw the white clay alteration. That Cameco's Millennium deposit, very cool. It was quite an eye-opening thing. And then when I was relogging core, I came across full ZKO4 and ZKO6, which had that same type of alteration, and they had a little bit of uranium in there. So we looked at it as a group, and eventually that turned into the next target area after Phoenix, and lo and behold, Griffin was discovered. So I was gone at the time, though. I left Denison in 2008. I went to Forum Uranium. They had Ken Wheatley as their VP exploration, and I had a lot of respect for Ken after working in the industry for a year and a half. To me, that guy is the godfather of uranium exploration. He's an absolute master. And so I went to Forum and picked his brains as much as I could, learn from him. But that was the same year that the world collapsed. And luckily enough, Hathor Exploration had made their Rough Rider discovery at that time. And Forum got me the job with Hathor. So in 2009, from 2009 to 2012, I was with Hathor Exploration. I started working on the Rough Rider deposit, and I put it during my breaks and everything, even minus 40-degree weather, while everyone else is having prolonged breaks. Where am I? I'm outside relogging core. I put together the first geological model for the whole deposit, and it basically told us that we were drilling in the wrong strike direction. So when we changed our drill orientation, we discovered 2 more deposits on trend, and then Fission got their start with their J-zone discovery to the west of Rough Rider, right on the same trend. So all they did was just line up all the drills that we were drilling with Rough Rider, and just made the J-zone discovery. So it's a great trend. Rough Rider's an absolute trend. Rio Tinto bought us out. To be honest, I was not a big fan of Rio Tinto and the way they did things. I didn't find them to be cost effective at all, and yeah. Anyway, so in May 2013, before then, I guess for basically a year before then, I tried to get out of Rio Tinto very quickly, and NextGen had come around. They had just staked ground to the east of Rough Rider, so I was familiar with the area. I had experience already seeing 2 zones being discovered. So I just reached out to them and said, this is who I am, and they liked what they heard, and they just had to raise money. So when they raised the money, May 2013, they brought me on, and basically the rest is history. Within a year of joining NextGen, we made the ACKIO discovery, and NextGen is probably one of the most valuable uranium companies in play right now. And the deposit, the ACKIO deposit, is a wonderful deposit. There's a nice high-grade nugget in there. That's the type of stuff everyone's looking for. You want those high-grade nuggets. But it started me thinking on this whole idea of basement deposits, because that's all I've been seeing yet. Coming around in the industry, you're always told that it's an unconformity deposit. Everything occurs right at the unconformity. But ACKIO was very deep. Eagle Point was deep at that time. Griffin is basement hosted deposit. Rough Rider is a basement hosted deposit. Everything kept pointing to these large, complex basement hosted deposits that everybody was overlooking. So I started conceptualizing this idea that there are more basement hosted deposits out to be discovered. And even with Hathor, there's a number of discoveries that I had made that people don't even know about. They're just a lot of little things out there. There's uranium to be found and understand how this whole basement system works. But we were getting taken out by Rio Tinto at the time, so we couldn't disclose anything. So yeah, after NextGen, I got into the rare earth space. Worked on some high-grade rare earths, which was very fun and exciting, but the allure of uranium brought me back. And in 2019, the guys behind the Oregroup, so Stephen Stewart, Charles Beaudry, they were looking at getting into the uranium space. And they wanted the right guy to run the show. And apparently my name kept coming across their desk. So again, by that time, I discovered 550 million pounds of uranium uranium. So my name kept coming across their desk. We met at PDAC in 2020. We hit it off. Charles and I really jived on the idea of looking for these basement hosted deposits, solely basement hosted deposits, assuming that the basement was a lot larger and everything got eroded. Just looking for the structures mostly. So yeah, we hit it off, and in June of 2020, we formed and listed publicly. I think and like I said, in our first drill program, we made a discovery following this thesis that we call Athabasca 2.0. So I think it's a very, either we're lucky or we actually know what we're doing, which is, I like the latter for sure. And of course, strong uranium fundamentals. I'm a uranium bull. I always will be. I love nuclear energy. This is why I do what I do. This is why I'm not on gold, because I don't see the value in gold. I love the idea of nuclear energy because it is green, it is reliable, it is consistent, low footprint mining. Oh my goodness, especially from the Athabasca, that is such a low footprint of a mine, and the energy that comes out of that material is absolutely mind-blowing. It's great. If you want the most environmental energy source out there, it's nuclear energy by far. There is nothing that comes near it. That's our future. So being a nuclear bull, being a uranium bull, I do like the idea of finding power for the future. When we set out to form Baselode, we said, let's not discover a deposit, let's find a mine. There's so many deposits out there in the Athabasca. As we move forward through this is the Athabasca Basin, northern Saskatchewan. This is what people know this as the world's largest high-grade uranium jurisdiction, and it is for many reasons. But if you look at the amount of deposits, which are all these little dots, and then all of these mining symbols as well, so there are mills in the area, but all of the mines were outside of the sandstone. There's a few that are just on the edge, and this is, even though this is in the middle, this is actually outside. Meteorite hit there, and there's no more sandstone in the area. It's this meteorite uplift, but there's uranium in this area, and they mined 60 to 70 million pounds out of there. The only two that are in the basement are McArthur River and Cigar Lake, or sorry, in the sandstone, because they're the monsters. They're the deposits that are over 300 million pounds and over 20% U3O8. 20% U3O8 is the most valuable mined commodity in the world ever. I've worked at Red Lake, Ontario. I worked for Goldcorp in the summer of 2005, and I got to see their showpiece of core, 100,000 ounce of gold, like the half to 3/4 of the drill core. HQ size was just pure gold. Absolutely amazing. I thought that was the most valuable rock in the world, but then I've seen 80% uranium on multiple projects, to be honest. And high-grade uranium is the most valuable stuff in the world. But the problem is that sandstone. That sandstone is an aquifer. It holds water. It is what it is. It is sand and it's stone. There's porosity. If you walk on the beach, there's porosity in the beach, which is why the sand is wet. That sand gets lithified and it retains water. So as deeper you go in this, the higher the water pressures, the more water volume. That's the problem. And so McArthur River and Cigar Lake both have to freeze the wall around them so that they don't flood. They both flooded twice. So the 2.0 concept versus the traditional unconformity style of mining and exploration, we're looking at simpler geology. Excuse me, no sandstone. The rocks are far more competent. Whereas as soon as you deal with sandstone, oh, it's a mess. You get voids and everything. It is not easy. Easy mineability in the basement rocks for the Athabasca 2.0 versus mining engineering difficulties. Great examples of high-grade deposits. Arrow that we talked about, Rabbit Lake, which was an open pit mine, 0.3%. It was one of the first uranium mines ever. Very significant because it built a mill. Eagle Point, which runs out of the Rabbit Lake, but that's a system that goes a kilometer deep. They basically found it close to surface. Uranium City, 70 million pounds have come out of 16 mines from there or more, up from the 50s to the 80s. Great jurisdiction. Again, a lot of open pits, added access, no sandstone to worry about. Average grade's about 0.25, somewhere around there for all of the mines combined. But that just shows that you don't need if you don't have the sandstone, then you don't need these high grades, and you don't have all of these other issues that come with it. You don't need to require freezing or high capex. So again, looking at summarizing everything. So anything in gray has not been mined. Anything in red has been mined. Some exclusions, Triple R and Arrow, because they are more recent, discovered this decade. Even Rough Rider, which I discussed and worked on, Phoenix, Griffin. A lot of these deposits, yes, they're new, but there are some like Midwest, discovered in the 1970s, Tamarack discovered in the 1980s, McLean Lake discovered in the 70s, Millennium discovered in 2000s, Centennial discovered around the same time, Shea Creek's been around since the 90s, and they're all huge deposits. These things are tens of millions to hundreds of millions of pounds of uranium, and they haven't moved in 50 odd years. That's crazy. It's absolutely crazy. So you have to think, why? Just why isn't that there when the demand has been there? But there's no advancement for it. The thing is, as soon as you remove that sandstone, you reduce the water issues and you're manageable. Back in the early 2000s, or predecessor to Orano, so I guess it would have been Kojima back in the day. They tried some underground mining at the Midwest deposit, and they were pumping out 25,000 liters of water per day. It's a lot of water, and if it's in contact with uranium, then you have to consider it to be contaminated. So it's not a good situation. If you reduce that water intake, and this is tried, tested, proven true in the Athabasca Basin, if you have less than 100 meters of sandstone cover, so less than 100 meters of sandstone cover, you can have an open pit mine. Yes, the higher grades are much better. Of course, they always are. But you can mine these things, and there have been. Key Lake was a 200 million pound deposit. Sioux City was, I think, a 40 million pound deposit. Some of these things are huge. They're absolutely massive nuggets, but they can be mined without any issues. They can be mined as open pits. If you have no sandstone cover at all, you can mine these deposits at lower grades and variable sizes. And that's the big takeaway. That sandstone, as soon as you introduce that sandstone, it just complicates everything. Even open pits, you can't mine these grades as open pits with 100 meters of sandstone cover. So no sandstone is a wonderful thing, and even just by looking at the schematic, you can see that there are a number of deposits that have been mined without any sandstone cover in this jurisdiction. Uranium City, Bluff Lake, Rabbit Lake, Eagle Point, to name a few. ACKIO fits that bill perfectly. This is exactly Athabasca 2.0. We're bringing exploration back to the concept of easy mining and low-cost mining in the Athabasca Basin. We're looking for these things. We're looking for a McArthur River. We're looking for an arrow, but out here. If you can bring arrow, this gray nugget, and bring it up to here where our green shells are, you've got the world's greatest uranium deposit, without a doubt. And we do believe that these things do exist out there. They just haven't been looked for. I'm just going to kind of skip through all of this here. We just talked about that. So this is the Athabasca 2.0 thesis. We do believe that the basin was a lot larger back when uranium was forming, which would have led to these basin-hosted deposits being formed. But since erosion and everything, we could have brought these deposits up closer to surface. So again, that's what the basin looks like today, but it has gone through a number of glacial events, and many academics do believe that there was at least 2 kilometers or more of sandstone on top of today's current Athabasca. The sandstone formed about 1.8 to 1.5 billion years ago, so yes, it's seen many glacial events. How big was the basin? We don't really know. There are some people who do believe that it linked up to the Thelon. But if you look at this map, you can see that there is something called the Riley Subbasin. And that subbasin is a part of the Athabasca Basin. So it's about 85 kilometers away from the current basin edge. If you look where our Catharsis project is, we're also about 85 kilometers away from the edge. So if you just do a simple ellipse, we can assume that the basin was at least this big at 1.5 billion years ago, back when the uranium event was happening and uranium was forming that long ago. But since then, everything's been eroded. So there we are, 1.8 billion years ago. It's part of a mountain building event. The mountains that some believe were larger than the Himalayas are today. So that's a huge mountain belt. And I've done videos with the comparison to the Tarim Basin, which are pretty interesting. They make a lot of sense and put things together. But you're looking at a super large basin here when it's actually forming between 1.8 and 1.5 billion years. In the next 1.5 billion years, you see a lot of glacial events, and then as it's eroding, and because you're closer to the basement rocks, you can have these little pockets form of sandstone. That changes a lot of things. But because they've been glaciated, and more recently, about 10,000 years ago, when everything retreated, we were left with a lot of dirt and topsoil and all that fun stuff, which led to a lot of vegetative growth. And it basically covers everything that could be at surface. So we call anything that we're looking for blind, because we can't see them at surface. So we have to rely on geophysics to make our discoveries and pick our drill targets. If we stick with this is a cross-section of the Athabasca Basin from east to west, but if we stick with the concept that, and this was what I was indoctrinated in when I first got into the Athabasca, but if you take the slope of the eastern edge of the Athabasca Basin and just run a straight line, let's focus on that. Run a straight line, and we take the scale, move it up here. So we're 50 kilometers away. Okay, we're 50 kilometers away from the current Athabasca Basin edge. Then we can assume that we are about 500 meters beneath where the unconformity would have been. That's a linear approach. If you know anything about basin topography or just basin architecture, it has subbasins and then plateaus, and then it has a slope and plateaus and slope and plateau, and it keeps going on in a format like that. That's how basins typically form. It's never a constant sink bowl shape. Subbasins, yes, but a larger basin, no. And that's the big change in fundamental thinking that we have applied to this Athabasca 2.0, is that the slope is basically flat. We believe the slope where everything is as of today really wasn't 500 meters beneath the unconformity. We think the unconformity was maybe 50 to 100 meters off. Everything just kind of plateaus. So here's the Tarim Basin that I was mentioning. If we take the modern day Athabasca and throw it on here, and we said, well, it could be 2 kilometers, we could have had more than 2 kilometers on here, you can add the thickness. But coming across, you can see that there are potential for subbasins. You can have a subbasin here, you can have a subbasin here, you can have a subbasin here, and even over on this side, you can have these subbasins that do exist if this was eroded down to this level. That's the concept of the Athabasca. And then you have your structures, your major structures, and that's what we're looking for outside of the Athabasca with no modern day sandstone cover. We believe these are the type of faults that would have had basement-hosted mineralization along them. So again, if we go back to that Athabasca cross-section, that wasn't supposed to happen that fast, there we go. We'll go back to this cross-section and let's just assume everything got eroded. Everything got eroded away. Look at that, you still have 2 subbasins within a subbasin. It's a fractal nature. That's just how these things work. They have subbasins, they plateau. They have slope and plateau, slope and plateau. It's how these things work. So here's the Athabasca. This is our cross section from north to south now. Here's the Athabasca Basin, and we do believe that there is potential for these subbasins to occur in northern Saskatchewan. Nobody's been looking for them though. Is there a possibility that we have the Catharsis Basin? Interestingly enough, on our first field program out on the project in 2021, when we were boulder prospecting, we came across some Athabasca sandstone boulders that were pretty large. And sandstone, it is very friable in nature. It will break, especially if it's been run over with a glacier. It will break and crack. And you don't typically find these tabletop size of boulders that are about a foot thick or thinner. I think it was like half a foot or 15 centimeters. But it was just this big slab of sandstone. It felt like it came from somewhere nearby. Because again, if it traveled a long distance on a glacier and multiple glacial events, it should have broken off. It should have been broken up into rubble. It should not have survived a long trek like that. So that really helps enforce the idea that there are minor subbasins around the Athabasca. Why is that even important? Why am I making a big deal about it? I just said no sandstone is great. So why am I now being controversial or contradicting myself? Less than 100 meters sandstone is great. If you don't, again, as soon as you get beneath that 100 meters sandstone cover, I'm not saying 100 meters depth, I'm saying 100 meters sandstone cover. As soon as you get more than that, that's when the water becomes an issue. You can still have sandstone, 50 meters sandstone cover, 25 meters sandstone cover. That's fine. That's doable, workable. But it changes our whole exploration strategy. Without the sandstone, we're just typically looking for basement-hosted mineralization. We've got our mantra that we follow. We do our geophysics that we're looking for, and we're looking for deposits that are typically along here. But if we introduce the concept that there is a sandstone, what that really does now is we still have that basement potential, but now we've also got unconformity potential as well. And the unconformity is typically where you have your super grades. Your 5%, your 20%, your 80% is around this sandstone unconformity. I'm not saying it doesn't happen in the basement system. It does. I've seen it. Again, Arrow is a good example of holding on to 80% uranium. But you don't see them as frequent in these basement-hosted systems as you do with the unconformity, just because the chemical change at that unconformity is so sharp and so drastic that it's a literal chemical electrical shock to the whole plumbing system, to the whole water system. Any elements in there just come flash right out of the water. It is quite an amazing event that happens at that unconformity. The redox potential is phenomenal. So that's why you get these super deposits there. But again, having those subbasins, yeah, a little bit of sandstone is fine. It increases our chance for higher grade uranium deposits. That's Athabasca 2.0. That is what it is all about. That is what we're exploring for. Hence why we say we're looking for a mine, not a deposit, because these open pits within northern Saskatchewan typically go from exploration to discovery anywhere from 6 to 12 years, whereas these underground deposits, especially within the Athabasca, Cigar Lake, for example, took almost 40 years to go from discovery into production, only because of the water issues. The mine flooded twice. They have a freeze curtain around it that freezes the rocks 24 hours a day, 7 days a week, 365 days a year. They don't skip out on the leap year either. That is a fully functional, operational freeze wall curtain that is constant. And if it goes off, they will flood the mine. So it's not even an economic issue to deal with at Cigar Lake. It is a huge safety issue trying to mine anything with these deposits down in the sandstone. Hats off to Denison Mines for trying something new with their ISL. It's taken a while for people to really start looking at these other possibilities. But yes, Denison Mines is trying something new, and it is absolutely great. Good for them. The other Orano's doing the SABRE technology, and SABRE is very cool. I think it has a little bit more of an application. In a conference in Vienna last year at the IAEA, Orano gave a talk about the SABRE technology and mentioned in that presentation that their SABRE technology would be a perfect fit for Baselode's ACKIO deposit. So that tells me that they are looking at our ACKIO deposit, which we'll discuss momentarily after Catharsis, which, yes, the larger mining companies within northern Saskatchewan are looking at us. So I think that means that they see the potential that we also see, that what we have is quite significant at ACKIO. But again, congratulations to Orano for trying something new and coming up with SABRE. That's revolutionary, and the Athabasca really needs it. But we still believe that these near surface open pit style deposits are the best way to go. If you find MacArthur River near surface, if you find MacArthur where we're finding ACKIO, 200 million pounds within less than 100 meter volume cube in every direction, within 25 meters of surface, you've got the world's richest uranium deposit. Your costs for mining that are negligible to what you would gain out of that. So yes, we're looking for these ultra high grade deposits, but in the best mining environment scenario possible. ACKIO, I've been talking about ACKIO quite a bit, and we do prioritize it because it is our uranium discovery. Mineralization starts as shallow as 25 meters beneath the surface. We do see it down to 190 meters beneath the surface and all those polygons there. On average, though, mineralization goes down to 110 meters on depth. However, we have seen mineralization beyond 200 meters, especially in drill season last year. We started seeing more. We started seeing our best hits at depth. But in our very first drill hole, we saw mineralization down to 320 meters depth. We do believe that mineralization continues along the structure in the area, and we will be looking for depth continuity this summer's drill program. Currently about 175 meters wide, measures 375 meters on strike, and is comprised of 9 individual uranium pods. We do have numerous intercepts with high-grade uranium being greater than 0.5% U3O8. Results from the summer really included the extension of Pod 7. So when we originally discovered Pod 7, we were drilling from the west to the east. So we were drilling down dip of this body. We realized that, came back this year, or last year, sorry, in 2023, and said, okay, let's cross-cut this thing. As we did, we've made a number of discoveries with Pod 7. Not only did we find that it is now thicker, but we've extended at depth. We do believe that Pod 7 attaches to Pod 4, making a much broader deposit from 32 meters beneath the surface down to deeper than 200 meters. So you start building up some tonnage once you have these larger dimensions. And if you think of a mining scenario, you've got 200 meters of mineralization that is continuous. That's quite a good sheet to follow in a mining environment. You don't have to worry about waste rock or anything. You're just going to be mining continuously for 200 meters. And we also found higher grades. We have discovered higher grades within Pod 7, and as we continue on this Pod 7 extension, we are finding even higher grades. I think our best hit in the area was 8 meters at 1.5%. There is an intersection right up here, 92 Energy, who are an Australian company. They have the other half of the ACKIO system. They call theirs Gemini. Gemini is deeper and it is smaller than ACKIO. We do have the shallowest mineralization right in this area, and it gets deeper this way and it gets deeper this way, but also, well, deeper and shallower. What they hit, what was it? It was 8 meters at 1% with a 9%, 10% over half a meter right in this corner. So we know that there is a high grade corridor up in here, and we will continue to investigate it. We've had a few high grade hits in this area, so it doesn't take much. If you think of McArthur River, I just mentioned it not too long ago. If you're looking for 250 million pounds, McArthur River's average grade at 25%, the dimensions of that ore body is 80 meters by 60 meters by 40 meters. It is a very tiny ore body. This distance here is roughly 80 meters. So you could fit a Pod 2 in here. You don't even need 250 million pounds. If you had 25 million pounds sitting in here, you could fit that in there at 25% with dimensions of about, I think it's 20 by 20 by 20. Our drill spacing is 25 meters. So we can easily fit a 25 million pound pod, which is typical of the Athabasca Basin area that we are working in, within this area right here that is completely untested. That's our search for this summer coming up. We'll be looking up in this area, plus we'll be looking for unconformity mineralization along this area. I think it pops up. Nope, not. It's in a different, a little bit later. So these are the two pods that we have near surface, Pod 1, Pod 7. This is Pod 7, yep. This is what we extended last year. You can see that coming across the strike of the deposit, we were able to increase the thickness. We are seeing higher grades, and we're seeing it at depth. We're also seeing it near the surface as well. Just some of our highlights from last year. I've mentioned most of it, but we've discovered new near surface mineralization, multiple drill holes with greater than 30 meters of mineralization. And those are thick intercepts. They're not these 1 meter, 2 meter, 5 meter intercepts. These are 30 meters of mineralization. That's mining environment. Pod 7 has grown in all of the dimensions that we talked about, AK23, 985, and 0.41% over 35 meters. That's huge, and that starts at 43 meters and a half true vertical depth. Plus, it has your typical Athabasca grades of over 1% over 7.5 meters. And that's typical of ACKIO. We were even hitting some larger intervals at depth. One of the better ones, hole 88, 0.32% over 16.5 meters at 167 true vertical depth. So we know that this system does get bigger and deeper, and then even beneath that, we're still seeing higher grades of mineralization. When you want to find uranium, you follow uranium. Just a quick summary of everything discovered in 2021, 1,600 meters. 2022 was our biggest drill season. Uranium was hot, and then the markets kind of died, and we stayed kind of minimal for 2023, focusing more on delineation drilling, increasing our drill spacing to 25 meters instead of 50 that we were drilling on. We still have some more. Assays are actually all in. Sorry, that needs to be updated. That needs to be updated, but assays are all in. We have no assays pending. Some of the highlights of the ACKIO system as an entire hole. These are some of our better holes. 0.9% over 31 meters. And again, that starts within 70 meters true vertical depth. That's incredible. Hole 52, 0.6% over 25 meters. Starting within 28 meters true vertical depth. You're not going to find these intersections anywhere else in the world. Not this shallow. Even same with these type of intersections. You're not going to find them anywhere else. You can find higher, yes, of course. F3 is pumping out some great results. UEC at the Christie Lake project at UEX used to have amazing results, typical Athabasca high grades. But as far as in any other jurisdiction in the world, you won't really find anything better than those. But even in the Athabasca, you won't find anything shallower than what we're seeing here, which is, again, that's the uniqueness that we have here, and that was the thesis from day one. We completed quite a bit of exploration in 2023. Very happy with everything that we've done. The Catharsis drill program completed 1,630 meters in the very first drill program on that project in areas that were never explored. That project's never been drilled before. So we were the first company to go in there and drill that project, which I think kind of emphasizes our unique approach, that we're not following everyone else. We're trend setting almost in a way, because we have an idea, we have a vision, and we're not restricted by others' preconceptions. We have our own thoughts and our beliefs, and I think as we continue to explore, especially on Catharsis, I think one of the things we found in Catharsis was very encouraging, that our thesis is correct, that we could have a sub-basin on Catharsis project. So we'd be close to sandstone. We'd be close to where that unconformity was. Yeah, and that we're drilling Catharsis right now. We just had a news release out on Thursday the 15th that we are drilling. ACKIO, we drilled again with the definition expansion drilling, really trying to push this into an NI 43-101 mineral resource. We did a little bit of exploration. We were seeing little sniffs of uranium, but massive alteration here and there. And then we did one little hole exploration. I'm glad we did that one, because now that is out of the way and on to bigger and better things. We will come back to ACKIO later this year, but right now, as I mentioned, our Catharsis project is up and going. We are going to be drilling in this area. We've got a number of targets that I will highlight here very quickly. Catharsis is on that trend with Key Lake, full number of other high-grade deposits. You can see some high-grade uranium occurrences at surface here, but they're just spot samples. We tried to find these in the field. We couldn't. We're going to fly it with airborne radiometrics, see if they're legit or not, or if they were a spot sample and removed. But we do see structures and other alteration features on this project that would indicate there is potential for deposits to have occurred here. And then we'll fly the survey. Well, we're drilling right now, and then we'll fly it with an airborne radiometric and magnetic survey, high resolution, really pinpoint some of our other target areas. The white box is where we drilled last year. It's actually much tighter than that, but we stayed in one area, put a number of drill holes in to really learn about the geology and the thesis behind the area, which we basically did in last year's drill program, and we're very comfortable moving forward with it. So we drilled, if you can see the mouse, we drilled up in this target area last year. We have to go back there because it's still open. We hit 2 alteration systems. One of them had all the necessary precursors to demonstrate that it carried uranium. What we found, so in that drill hole, that was an oxidized fluid system. In the other drill hole, we found a reduced alteration system that looked like it's typical of Athabasca style of deposits. But we didn't find that redox contact, and that's what we want to find, because that's where you precipitate out uranium, at that redox contact front. So we do have to go back in there, but we decided, while the uranium market is hot, we know that area has potential, but we want to see if we can fast track ourselves to making a discovery. We feel that area from last year would take a few more drill holes to get to properly, like a more precise drill program than what we want to conduct this year. This year we want to do very hot, quick exploration on multiple targets. So just to go through some of those, and they're all prioritized on things that have led us to discoveries. Again, we've got a history of discovery already. If we go up to target area A is up in the northeast part of Catharsis. If we go up to there, you can see some of the magnetics as the background, but then these weird shaded colors are the gravity anomalies as well. I do not have the EM on here, just showing gravity and magnetics. But if you look at the shape and sizes of these things, they're kind of similar, especially there and there. There's another target area up here that I personally like, but we'll see how these ones pan out first. The reason why is because this is the ACKIO gravity anomaly to scale, the same parameters, has that same type of shape. We know that the structure is potentially different here, but just seeing the potential size of these gravity anomalies, that we're looking for the right thing. We're also in an environment that has a similar geological type, that we're seeing a lot more mafic and calc-silicate rocks out in this area, which is very typical of ACKIO. That's not typical of Athabasca exploration, where they're looking for a different type of rocks. They're not looking for the calc-silicates, but having the same type of lithological environment, which is a lot of those high-grade uranium showings that I showed were all associated with calc-silicates. So having the same geologic environment that has uranium mineralization to the northeast at ACKIO and high-grade surface showings here on the project, we do believe that this geological environment has the potential to have uranium deposit on it. And if these targets hold true, which do correlate with the EM as well, then yes, we're very hopeful that we can have multiple deposits in target area A. We'll look at target area B, which is also very similar to target area C, which was down here. They're both chasing rare earth elements. That's something we don't really talk about too much at Baselode. I'm a rare earth guy as well. I spent 2016 to 2020, right before I joined Baselode, in the rare earth environment, in the rare earth marketplace. I really learned a lot about it. I see a lot of value in the technical applications that rare earths play in the world. So much like nuclear energy, I think rare earths are absolutely phenomenal. I think what they've done for us, revolutionized our whole computing systems. Man, we've got pocket computers that have more power than the first computer I used back in the 90s. It is absolutely crazy what you can do with these phones, and it's all thanks to rare earths. It's all thanks to rare earths and magnets and other applications that come out of these things. So we're big believers of rare earth elements as well. And that trend that I showed, target area B, target area C, they have the same rock types as the project that I worked at that was called Alsace Lake. They also have high-grade rare earths within them. Very encouraging. 4% material, 2% material. They have a higher ratio of heavy rare earths to light rare earths than Alsace Lake does. But this rock, for example, is the same type of rock that is from Alsace Lake. But this is from our Catharsis project. It's a biotite schist, also known as a glimmerite. And if you look close enough, you can actually see some of the rare earth minerals, i.e. monazite, within here. But so yeah, we'll target that. We'll target some rare earths. And even in the Athabasca, at Alsace Lake, in the Athabasca Basin, there is an association of rare earth elements and uranium. Not one-to-one. And there's no specific reasoning why. My belief is that these biotite schists are part of really deep basement structural events that were forming pre-deposition to uranium. But some of the uranium that we see in the Athabasca could have been leached through remobilization of these structures, and uranium could have followed up. So this could be a deeper root system. I've seen, it's actually not talked about, but McArthur River does have some rare earths at it. It has some pockets of rare earths that are of potential interest. Elliott Lake, Ontario, which is actually my hometown, and I never knew this until I started working in the rare earth industry. But Elliott Lake, Ontario was Canada's first rare earth operation, and Elliott Lake's known as a uranium capital. Lots of uranium at Elliott Lake. But it was also Canada's first rare earth operation. But all of the rare earth, was yttrium, and it was a free-floating mobile form of yttrium. It wasn't associated with a mineral. So they actually did like brine recovery, and they tried, what do you call that? They tried mining it, heap leaching. They tried heap leaching, mining it too, out of the rocks. But it didn't really pan out too much, and they saw no value in it. There's your history fact for the day, though. Rare earths and uranium. They have good correlations, especially up here in northern Saskatchewan. Target area D. Love target area D. We all feel very strongly about it for multiple reasons. If you look at this image, we'll actually zoom in here. If you look at this image, you can see a lot of northeast, southwest trending features. They're very long. They're very continuous on the right-hand side of the image where the mouse is. If you come over to the other side, you can see these same type of features, but they're now dipping in from northwest to southeast. So they've changed their orientation. These are the rocks. These are the different rock types. And this is scales of tens of kilometers. So to change your orientation means you have to fold the rocks. And to change from basically 90 degrees, you can see here to here, that's a big change. You really have to fold your rocks. You have to put them under pressure. And when you do that, you're going to break. You are going to break your rocks. And you can see that in this image here. This is a very quick structural schematic. And you can see where all these rock breaks are. That these features, these magnetic features, are no longer long and continuous. They are broken up, shattered, displaced. When you shatter rocks, you're creating an area for fluids to move and migrate. That's how you get your alteration. That's how you get your uranium. You're not going to bring in uranium in a granite that has no fractures in it, because there's no permeability, there's no porosity. Rocks need to create that, and they do it by fracturing. So we look for those areas that have a high intensity of structures and fracturing. You can see the same type of thing in the PLS, Patterson Lake South Corridor. Scale's much different now. This is like 50 kilometers long. But the ACKIO deposit, which is this one here, which is what I was part of the discovery, and then the Triple R deposit down here, they're all along the same trend. But if you look at that same type of feature, that you've got these long linear magnetic features that are continuous over on the right side, and then they change their orientation, but they're still long and continuous on the left-hand side, and then in the middle, everything's all broken up and mashed, not nearly as transparent. Same type of structure. Same type of structure. So we're seeing these fractal patterns of uranium in a uranium environment, in a uranium field. And what we see it in nature too. I like this example because when I consider this stick to be on the ground, and it's going to sit there and get exposed to the environment, and it's going to start to break down. Where's it going to start to break down? It's going to start to break down here where it's solid still and encased in bark, but even the bark doesn't really matter. If there was no bark here and it was all still exposed, this area here would degrade the fastest, simply because it's got more surface area. And that surface area would increase the amount of activity that occurs along it, especially with water. It would take a lot longer to degrade this, even without the bark, than it would this. And rocks behave the exact same way. So when we come back to this example, and you can see the target area D gravity anomaly right here in white, and we've got all those structures in this place. The same when you try to line up the magnetics with the stick, which is kind of accurate here, but it emphasizes that in some area you're going to break. You're going to break at the neck bend, and that's what we're seeing in these rocks. So you can see it here in the gravity image as well. This image is kind of important because right here, so that anomaly that we're looking at, target area D, is right down in here. This is the longest, most continuous, deepest gravity anomaly on the entire project area. So is this a huge structural environment? And again, we want structure because that promotes fluids. We don't know if uranium was contained within those fluids. That's the always unfortunate thing. We don't know. We wish that were true, that every fluid had uranium in it, but that's not always the case. So we do our best to try to pick out the targets that think they would have uranium. Well, at least find the most intense fluid systems, because some of these uranium systems that I have seen have been the most fluid intense systems I've ever seen in my career. You want a lot of water. You just that water has to have uranium in it. That's the only caveat. Sticking with target area D though, and if we looking at an ACKIO, so when we targeted ACKIO, we had a very simple approach to it. And looking at the conductor, you can tell which way the conductors dip. Geophysicists run their magic. All of the conductors within this red ellipse are all dipping the same direction, same dip angle, all to the southeast. And that's the same with these conductors up here. They're all dipping at around the same angle to the same direction. So they're all continuous. Once you look at these two conductors though, there's a wobble. that they're not dipping in the same direction, they're not dipping at the same angle, they're slightly more vertical, maybe even dipping in the opposite direction. That's exactly what we targeted at NextGen for ACKIO associated with a gravity low. Even right here, you can see there's a bend, boom, boom, in that conductor. So you've got many things overlapping in this area. Looking at the background, the magnetics is the background, you can see that there's a gap in the magnetics between the greens right here, and you're also in a magnetic valley. There's so many things happening in this one little area that it screams to be drilled. We look for these overlapping anomalies, and these are the type of things that lead to deposits. I have drilled similar things in the past, and they haven't been deposits. They've been huge alteration systems, don't get me wrong. But the reality is sometimes there's uranium, sometimes they're not. But we try our best to find uranium, because you can't detect uranium as a whole. If we're right on this, though, a big benefit is that we're about 300 meters away from the haul road that goes up to the Key Lake mill. So if we find an ACKIO or a McArthur River, we're talking that 20% average grade material in this area, we're 300 meters away from a road, which is 100 kilometers south of a pre-existing and licensed mill. They would take this material in a heartbeat, and it would be very easy to provide the infrastructure. That was also part of Athabasca 2.0, is that we looked at a lot of places. Because we were so early into Athabasca, we could have staked the entire basin if we wanted to, but that's not our strategy. We realized that some areas are easier to move, some areas are not, because there are permit issues, there are water issues, there are environmental issues, there are logistics and acquisition issues. Can you get a road in there? We took all of that into consideration when we staked all of our projects. All of our projects were staked on the exact same criteria. That wasn't just founded on geological principles. They were founded on the potential of finding a mine and the capital intensity required to build a mine. All of these projects are meant not to have a mill, because the mills are in the area already, especially the Key Lake mill. So we don't want a mill. We don't want to build a mill. We'd rather toll mill everything, but we just want to find the right deposits that do get mined. So having an anomaly like this with close to infrastructure, this is Athabasca 2.0, textbook example. We just have to prove there's uranium here now. Drill's on site. We have the drill on site. Looking at that wobble just on a little bit more. This is the Griffin deposit again, which I mentioned earlier when I was with Denison Mines. Very close. Well, a lot of history there, but the foliation, so the rock fabric, basically telling you which way the rocks are dipping and their orientation. But these two here, to the north and to the south, are the same. But when you look at the ones at the deposit, they're all different. So there's your wobble, where everything up here is all oriented the same as everything all over here, but right where the deposit occurs is a wobble. And it's basically, they're always caused by structures, by these sigmoid type structures. And that's one of the things I look for. ACKIO, again, which I was part of the big discovery. ACKIO's right here, leading geologist behind the ACKIO discovery. A lot of this was based on my work, but if you look at all of the foliations or structural fabric, they're all basically dipping in the same direction with the same orientation. However, when you get to ACKIO, that's the only time that you see something that's basically that's pure vertical, and that's the wobble. So target area D has that wobble based on geophysics. We just hope that it's true with uranium. Later on in the year, we're going to our Bear project. Again, like I said, we're fully funded. Our focus this year is discovery. Uranium is hot. We know we've got the skill sets to make discoveries. We believe we've got the projects to make discoveries. Investors are looking at the uranium market. If we can prove that we can make another discovery, I think that we will be looked at favorably within the uranium market and really propel ourselves to the top of said peer group. So we're putting a huge focus on discovery. If we make a discovery at Catharsis, great, fan-freaking-tastic. That will not stop us, as we're, again, committed to making as many discoveries as possible this year. What's better than making a discovery? Making two. What's better than two discoveries? 3. So in May this year, we're going to our Bear project, all outlined in black. Here's Key Lake. Catharsis is south of us. Be helicopter supported again, but you can see we're on another trend that's kind of associated with Key Lake. I'm not going to get into details on this. As we get closer to each of these drill projects launching later on this year, we'll do some more in-depth videos as we've done for Catharsis and other projects in the past. But we're not going to build up the stories with them while we do have a drill program on the go. But Bear has a really wonderful target right down in here that we're gonna drill off. Hopefully does have all the same characteristics for making a discovery. It has a potential for a superstructure. If you follow that white line, which is the Key Lake superstructure, you can kind of see something similar cutting through here as well, but it has a slightly different orientation, and it occurs right down by where our gravity anomaly is. So we do think we've got the right things in there. ACKIO, again, we're going back to that in June. We're going to do an ANT survey, ambient noise tomography, ground to satellite system. Has some merits, but we're going to be investigating deeper parts of the structure, looking for deeper roots of mineralization, and we do believe they occur up here. We're also going to be drill testing down to the south. As I mentioned, we're going to be continuing the high-grade exploration to the northwest. Yep, that's the depth potential. And we're going to be exploring for the Athabasca unconformity style of mineralization around here. We have less than 100 meter sandstone cover. We have a huge fault that offsets this contact right here in the sandstone. All of the drill holes in here that have intersected sandstone all show uranium style of anomalies. Anomalies that I have seen that have led to unconformity style of deposits. And they're wonderful anomalies. They cannot be ignored. They have to be followed up. So we've got quite a large project planned for just drilling this contact in here alone, really looking for that high grade unconformity style of mineralization. And then we'll also be exploring our Hook project. So ACKIO is part of the Hook project, but you can see this big magnetic structure here, and that's what Hook was really staked on. We identified this structure as being a world-class structure that could have uranium potential. It's a scar on the face of the Earth, but there are some other anomalies right down in here that we want to drill test. It's basically the mirror ellipse or the mirror image of the ACKIO. ACKIO is at the north end of this structure. These would be at the south end of it. It just has so many good things going for it. There's so many overlapping anomalies in this area that it is absolutely crazy. So seeing the chain of gravity anomalies is very encouraging, because typically these deposits occur as chains, beads on a necklace, pearls on a necklace. Our shadow project, we love it. That was the first project we ever staked. We got a lot of people interested in Baselode because of the shadow project. Unfortunately, since October 2020, we have been in consultation about the project. It is ongoing. I would like to see it resolved, but it is very, very strenuous. Not as far as time or cash is concerned, but just trying to educate the local groups in the area. They keep comparing us to Fort McMurray in that we're oil and gas style of operations, which is totally not the case. And I think hopefully with this year, we can further demonstrate that, because we do have a number of exploration agreements signed with communities up in the area. And hopefully we can demonstrate being good working partners, socially conscious, environmentally responsible, and just keep trying to win them over with the best work that we possibly do. Exploration plans for this year, as mentioned, just summarize everything. We've started drilling at Catharsis. Very happy to be back on there. 5 target areas, 8 to 10 drill holes. I showed you some of those target areas, not all of them, but yeah, absolutely compelling targets. They have to be drilled. If they're not drilled, then yeah, we're not doing our job, and we're not doing shareholders justice. We're drilling the best of the best targets. Well, there are more targets on the project just within a certain area. But we're drilling the best of the best targets. There are other targets that I would love to drill as well, but we are constrained by time. I'm going to be following up with an airborne survey that, again, will highlight more targets and surface work. But really a lot of action is Q2, Q3. May we go back to Bear, or we go to Bear. We've never been to Bear. We will go to Bear for the very first time, drill that gravity anomaly area, 2 targets around there. And then in June, we should be back to ACKIO doing our expansion delineation drilling. Again, mentioning the target areas around there, and then the Hook project, where we've got a number of targets. Airborne ground geophysics, as typical, we like to continuously prioritize airborne surveys more than ground because we have learned to use airborne. So we've been very efficient with our exploration expenditures, that we don't do a heck of a lot of ground targeting. We've been able to rely on airborne anomalies, drill those off, determine if they're uraniferous or not, and be able to go on to the next one. We've put a lot more of our exploration funds directly into the ground than into trying to refine target areas left, right, and center. I think we've been very good at what we do. And the NI 43 and 101 mineral resource. This slide's out of date, but yeah, uranium price has taken off. It's like another 2005 bull run. But this one's so much different. The fundamentals. I've been to a couple of uranium conferences and talking with some of the traders, guys who have had 40 years careers working in this industry, and they have all said the same thing, that they have never seen a uranium market this hot, not since the 60s and 70s, 80s, when nuclear energy was really taking off for the first time and there were subsidies everywhere. This is the same type of environment with the build-outs being done in China and India. It's absolutely incredible. As of our last financing, we've got about 133 million shares outstanding, 40.5 million warrants and options, share price of 39 cents gives us a market cap of 52. The share price chart on the right is out of date as well. Didn't realize that wasn't updated. We're floating around 39 cents. When the market took off, we were along with the ride. I think we were at about 55, close to 60 cents. But then we announced our financing, and the market did not like that at all and took us right back down into the 40s. And then the market has been kind of hurtful in the uranium space and just overall as of late. A lot of red. We're down to 39, but with another discovery, I think that we will see much higher prices. And I think this is an absolute wonderful floor level entry point to get in for any investor at this point stage. We've got nothing but upside potential. We've got a $12 million exploration commitment. We have to spend $12 million on exploration this year by December 31st, 2024. If we're good at what we do, we'll make another discovery.
Yeah, so I had a bunch of questions. You answered a lot of them. So I'll try to cover some gaps, I guess, that I can see with the time that we have left. So one thing we always like to ask, what's your personal net worth allocation approximately to shares, essentially? What's your exposure?
I've invested personally into the company. I'm not a very wealthy individual, that's for sure. I've been a geologist all my life, so.
Yes, percentage-wise is what's important.
Yeah, percentage-wise, about 1% or less of total outstanding shares.
And as a percentage of your net worth,
what percentage of my net worth that has gone into the company, or that is related to the company?
Yeah.
Oh, geez, a lot. Let's say I'm writing a lot on this. A lot of my net worth is on Baselode.
Okay.
I can't give you a percentage over 50. But
excellent.
Yeah,
that's pretty much all in. So that's what we like to hear. You're an Oregroup company. We've spoken with American Eagle at depth previously, so we won't go through that entire thing. But this importantly affects your burn rate, which should be very low. If you weren't drilling, you're sharing a bunch of costs with the other companies in the structure. Could you tell us what's the burn rate per annum if you were not to drill at all?
If we weren't to drill, our burn rate would probably be around 80,000 a month. So per annum.
Yeah.
Per annum, right around $1 million.
And that's Canadian dollars, of course.
That's Canadian, correct? Yes.
Yeah. Who are the main institutional owners? You have a quite impressive, actually, percentage of institutional funds for being a smaller company. Could you highlight some of the people?
Yeah, I think we misrepresent institutions on there because a lot of those they're really retail brokers. Firms like Red Cloud, WCPD I guess they just do the charity front. But there are no major institutions like a bank or anything like that. We do have a lot of other funds. Sprott, Sprott's come in many times. Dundee, groups like that. We don't have any major institution.
Okay. And with the recent financing, I guess the market didn't like that, but that's almost always the case with financings. Could you outline why you think it was the right thing to do, just briefly?
Yeah, it gave us the money to do more. We analyzed. We had everything set out in our budget for when we did our last raise, October, December last year. Everything looked good, but then all of a sudden costs started going up everywhere across the board. Not like food, helicopter drilling, especially in January. A helicopter company came back and said, okay, we're going to increase our costs. A drill company came back and said, okay, we're going to increase our costs. Our employee salaries, I'm paying my employees more, they've gone up. So everything just started going up. And then we weren't looking for more money. We were slashing. Our drill programs and our geophysics mostly, saying, okay, well, let's reallocate these funds as best as possible. And funny enough, these funds are basically brought to us. Red Cloud said, hey, we have $5 million that people want to allocate to Baselode. Do you want it? Yes. It really wasn't a hard decision. We knew, because market is hot right now, we want to do more. So we've increased all of our drill programs now. We've increased all of our geophysical programs now. We want to make a discovery. We want to do it properly. We don't want to walk into a target area and just be like, let's poke a hole here. No, we want to be able to put 2 or 3 into a target area to comfortably walk away or make a discovery. But we couldn't do that with what we had. But now we were happy with what we were able to do. We would have achieved it all, but we're much happier with what we have now. And just some of these target areas, they need to be explored, and they need to be explored and drilled this year.
Yeah, so I mean, you feel like the cash top up will allow you to kind of to falsify at least the targets, or you get, as you say, comfortable walking away. One hole can be difficult to do that. Obviously,
it was a raise at the highest prices we've done in almost 24 months. So we felt that we were doing justice by not diluting as heavily as we had in previous raises as well.
So with the kind of the flow through component, what was the average price that you raised at, and how many dollars in total?
It was $6 million raise. Average price, well, because most of it was flow through components, the average price was closer to that 65-cent range.
Yep.
If we had to average down, it'd probably be around 60.
And with all of your warrants, I guess mainly options are mainly held by executives and employees, I take it. But on the warrant side, when do they expire? What's the strike price at, and who holds them?
I used to know all of that, but over the last few warrant expiry periods, they've been expiring because they were set at higher prices. Our average strike price has come down. It used to be at around 70 cents, but it's definitely come down quite a bit. I think we're closer to 55 cents. No, 55.60. The next, 2024, I do believe, was under the impression there was some coming up in April 2024, but I'd have to look at that again. Yeah, sorry, I can't answer that for you. It's all up on our quarterly reports, which are available on SABRE. Very easily accessible for anyone to get access to.
Yeah, sure. But point being, it's not a substantial amount of warrants. How many warrants are outstanding?
24 million.
24 million, and most of them are quite. Yeah.
Yeah.
Do you know if a substantial bulk of those are expiring soon, or
no?
Are they further out?
No, they're further out.
Okay. So that could be cash that you will get, say, if you discover something. I mean, the share price goes up to 60 cents, then many of them would probably exercise, and that could be a tool for you to potentially drill even more.
Exactly.
This year.
Yes. Prior to 2022, we had a almost 100% warrant execution rate. We were 97, 99% warrant execution rate for almost 2 years, and then our share price just came crashing right down.
Do you feel like that would be the strategy? I mean, say Catharsis goes brilliantly, and you guys are at 70, 80 cents in May, June, when those assays should be out, or maybe even earlier. would you just extend the program right away, or would you kind of safeguard that cash, or would you take the opportunity to allocate those meters?
Depends what we're hitting. If we're hitting monster grades, if we're hitting monster intersections, we would have to expand immediately. But we'd want to cash up to continue exploring. Again, sure, we'll have one discovery, great. Let's go for more. Bring on a second drill.
And
we wouldn't
plan
have to cash up right away. We could always cash up later because we could defer some of the hook exploration and just cash up in the interim.
So, I mean, you say you want to kind of tag off multiple discoveries. I mean, if Catharsis goes well, you will still move on. But if it goes really well, I mean, if it's like tremendous,
then
you're going to have to stay.
Yeah. Oh, yeah, for sure. Oh, yeah. No, we would look for a summer drill program as well.
What would that look like? What would be kind of okay, forget about the other targets for now, we're going to have to stay and put more holes into this. What would that look like?
Another ACKIO type of discovery would do it for us for sure.
Yeah.
Again, when you've got the logistics and infrastructure right there, it's almost a no-brainer.
So what would an intersection to confirm that for you look like?
Oh, anything with over 10 meters greater than 0.05%. That would get me encouraged. Even 5 meters at 0.05. Any significant sniff, like any. I've seen what little things have led to. Arrow was a great example. Again, some of the holes at Arrow, if you go back to the original 10 drill holes, you can see how little and small some of those intersections were. But they led to a 300 million pound deposit. So you can, if you understand and know the signs, you can follow those and know that you're in the right area.
And then, I mean, if we briefly talk about Catharsis, the rare earth target, people might be familiar with uranium. It's a bit simpler to kind of work with the value there. Obviously, this would be a hard rock target, I take it. So you can work with lower grades, if I understand it correctly, generally speaking. It's more, with rare earths, or is it clay that's a lot more economic?
Yeah. Clay depends on the mineralogy too, though. They say clays are more economic at lower grades, but that's in China.
Yeah. Or you can be a pig.
Yeah, exactly. No, that's so hard rock is typically you need higher grades. You need the right mineralogy. Number one, that's always the case with rare earths. There is so many different rare earth minerals out there, but only 3 or 4 of them are economic. The other over 100 of them are garbage and shouldn't even be sought after. But yeah, it would be a hard rock type of strategy. Hopefully we would have a significant grade to it. But being on rare earths, working on a project, I've done all the lab scale testing on previous projects, know the path forward to concentrate rare earth minerals at a project site. And the beautiful thing about this whole strategy is there's a rare earth processing site in Saskatoon, which is where I'm talking from now, and it's where I'm 6 hours south of Catharsis by truck. So if we have a rare earth discovery, we've got a processing plant right down the road, all trucking distance. So it's these SRC, Saskatchewan Research Council, who are partly funded by the federal and the provincial government. They built a rare earth processing facility, and they're going to need feed. So it makes sense.
But since you're a uranium store, right? Your investors follow for uranium. They might not know. I mean, what does I think for it to move the needle right away, it would need to be a very strong hole. What would that look like?
Same with us. It would have to be a very strong hole for us. If it's negligible, we walk away. But we're curious about the area, which is why we have to do. What would a good hole look like? I don't know, 10 meters at 2%. More would be fantastic, but I think that would be a pretty good start. It wouldn't be a carbonatite, so it's a different type of rock.
How shallow are you targeting for this?
Very shallow, 50 meters depth, shallower.
And what's the kind of, with rare earths? I mean, 2% of uranium certainly should be a lot more valuable than 2% of rare earths of trio, I guess, almost always.
Yeah.
By a stretch.
Yeah, there's a lot of things you have to work with on trio though. Again, your heavies to lights ratios, certain elements. There's a lot of garbage rare earths that are worth nothing. And
but I mean,
uranium.
Do you feel
uranium's what we're after. We're always after uranium, but we know we've got rare earth targets on the project too, within an area that we feel that we can reach and has uranium potential as well. Both those targets have uranium potential as well, but we know them right now as rare earth targets just because of the rocks that we've seen.
Okay, I think we'll leave it at that for now. By the way, what's the order of drilling between B, C, D? What's the order?
D is number 1 just because it's the closest to the camp, easiest to get to. Again, drills on site. They should have got a lot of things done last night. Hopefully they'll finish up today and hopefully have it spinning by today, being Friday the 16th. But yeah, D is first one logistically, not just because it's our favorite, but it's our logistically the first one. Then we'll probably go CBA.
Okay. And doing all of these holes, when do you expect them to be all drilled out, completed, and when do you expect to see assays starting to come in and for it to be done?
End of March would be when we're probably done. We should be done sooner than that, but end of March sounds like a plausible time frame. Yeah, we should be done way sooner than that, mid-March even. Assays would come out. We'll be running them in every 2 weeks. So we should have, or every week assays will be coming out. If there's a 4-week turnaround time, so mid-April as the soonest to start getting assays. Actually, no, sorry, we're mid-February, mid-March. Mid to late March would be the soonest that we could start getting assays, and it would probably wrap up mid to end April, which is perfect timing, segueing right into Bear exploration in May.
Yeah. So, I mean, generally speaking, you have kind of you will have results coming in starting mid-March, and then it will kind of trickle in.
Yep.
And
steady news flow from here to the end of the year.
Yeah. And you're doing these kind of the geophysics, like high-res mag, radiometrics. Is that kind of an investment you're making now to, if you find something, you have high resolution information to vector in and kind of drill out something, or what's the reason for doing it? Because I take it will not be, you will not have time for that information to inform your drilling that you're already doing it, like tomorrow.
No, it informs future targets. Again, Catharsis has a lot of targets on it. We're picking what really popped to us first as what we consider to be our tier 1. There are other targets that I think are tier 1, but the mag is kind of muddled. It's not a high-res mag, so we need a high-res mag to see certain features a little bit clearer. And the radiometrics, again, really to get out there on the ground and start picking up a little bit more of the geology of the area.
And for Bear, will you ever have the time to get that info before you start drilling? Or will that be done as you get to Bear site in May?
Bear, we don't need it for drilling. There was plenty of historic exploration completed between 2006 and I think it was 2010 that the data, the coverage that they did in the area is reliable. They did a ground-based geophysical survey over the area, over a much larger area of the project, but the anomaly that we're interested in was covered by that ground-based survey. So we're very happy with the data that we already have access to at Bear. We don't need anything else right now. We need to fly the project with airborne surveys, though, to keep it in good standing.
Okay. And if I understood correctly, you have some permitting that needs to be done to start drilling there at Bear. Is that done?
Everything's
all
done.
Complete.
Everything's done. We've got all the permits in hand.
That's very nice. And obviously you go through the targeting in the presentation. So, but at ACKIO, to give people a sense, I mean, with the drilling currently, ballpark again, it's not you can't really know exactly. But what's your feeling? What's the tonnage? What's the average grade right now?
Don't know the tonnage. Average grade about 0.3. If you take all of our news releases and just do a composite summary, composite a weighted average, sorry, if you do a weighted average, you come up to about 0.3% U3O8 as an average grade. And I think that's quite a lucrative grade. If you compare it globally, it is high grade, much higher than average grade.
Yeah, and I think we ran this calculation. I mean, it's quite simple for people to do, but I think that kind of translates to like $500 rock or something like that, depending on the U price. But that, obviously, open pitable, that's tremendous.
Yeah. I ran it. So I ran it at $70 a pound U3O8, and I think we've got a gold. I like the gold to uranium comparison, and it has basically 8 gram per ton gold comparison, but now at much higher prices. I can't think of a gold company that would walk away from 8 gram per ton open pitable gold.
No, and not to mention when you see like quite sweet intersections with like 1/1%. It's of course that becomes something else.
Yeah.
And with the entire backdrop of the not having to deal with the sandstone and stuff like this in this particular deposit, it should be very technically feasible to mine it cheaply as well. But so after the kind of the extension and delineation, actually before we go there, do you have no sense at all? I mean, I'm trying to push you here a bit to give some kind of number of where you would hypothesize how many pounds you have right now. How many pounds do you think you can get to after the expansion delineation? Obviously, it's highly random, I guess, what the grade turns out to be. But
I don't see an issue with trying to get to double digits. Like I think double digits are doable. The big takeaway and the best way I can answer this is I have seen many smaller uranium deposits get mined at lower grades historically. Even in the last bull cycle, 2006, 2007, I've seen smaller uranium deposits with lower grades get mined. Not in China, in countries with similar economics as Canada.
So put it this way: this allows you to kind of to define it at least, or constrain it upwards and down. After the delineation at ACKIO, and then you will do the initial resource in Q4. What do you think is the range of outcomes, depending on how successful the expansion is? Because as you say, if you extend the pod and that pod turns out to be continuing to be 1%, or then it can be a lot larger. So what would be the range of outcomes you see? Is it tremendously vast?
I really can't feel comfortable trying to answer that, because it can blow up in our face, or it can be average, it can be what we expect, or it can be far better than what we can expect. I can't.
Exactly.
Yeah, I can't really try to come up with an answer on that one.
Okay, but your 0.3 currently, you have significant intersets. Tracking the pod upwards, how many? I mean, could you explain a bit more in detail how you will expand those meters? How much deeper will you track the system? Because
yeah,
I mean, it's open, right?
It is open. It's open at depth. It's open on strike. We're going to try to track it 500 meters to a kilometer on strike to the south. We're going to the north. We're limited. Again, with the high grade section we're looking at, to the north, we're limited by about 100 meters. Depth, we've budgeted out about 400 meters depths for drill holes, but we're going to wait until we see the results from the ANT survey, because that's meant to map out our deeper structures. And once we kind of figure out those, then we can put a better drill program in place and figure out how deep we need to go. But for the current, I think it's 500. Yeah, we're budgeted down for about 400 meters to 500 meters.
To depth.
Yeah, to follow up the system at depth. So we'd be doubling our depth. Like most of our holes are around 200 meters.
Yeah, so the ANT survey, is that to be conducted before you arrive to site with the rig, or will it be simultaneous?
Yeah, in May, and rig gets there, and the drill will get there in June.
Okay.
And the turnaround time on the processing of that data is within days of acquisition. It's a very quick survey.
Okay, and kind of I have a couple of more questions if it's okay. So the distribution of the grades in these deposits, I mean, can you kind of explain how variable that can be? Can it, like, within 50 meters just transition to some tremendous grade randomly, and then you have 40 million pounds, because it can be so small footprint?
Yep, absolutely. We drilled a hole for next gen at Arrow where we cut the two high grade zones. So Arrow has high grade zone here and high grade zone there. We had a drill go right in between the two, 10 meters away from high grade mineralization, and you'd never know it. Never have a clue. A Rough Rider deposit was originally a Cameco deposit, and they dropped it because their model was looking for unconformity mineralization. If they would have drilled 10 more meters beneath that drill hole in the area, they would have discovered high grade mineralization. But they stopped an alteration and said, no, nothing here. You can be right beside these things 10 meters and not even know it. So it's that quick and that easy.
Yeah. Okay, that's useful for people to know. And then I just want to briefly, you mentioned SABRE technology being very applicable to ACKIO. Can you explain why they made that comment?
Just because the way that the technology is designed, it's meant to be a low surface impact mine, and it's really meant for shallower style of deposits that you're not going to do an open pit or you're going to go underground for. You can do it all from surface. It's an air core type of system. Everything's brought up by air. So it doesn't want super high grades either. It doesn't want your 80% because that's really, really heavy. It wants your 0.3s and your 0.5s and 1% because that's a lot lighter. And you can move stuff up. So it was designed specifically for their lower grade deposits that were uneconomic through open pit or underground mining.
And then finally, James, we always like to ask, what would be your 3-year vision for Baselode?
3-year vision, much higher share price, multiple deposits being delineated, and ACKIO working towards becoming a mine. We've already started the process internally, and we've talked to a lot of different contractors who build things. In the closing, I meant to talk about this during the presentation, but if you consider the capex for ACKIO, and we've talked to a number of different contractors up north about this, but to build the road, we're 30 kilometers away from the haul road to get to the Key Lake Mill. Let's say we're 40 kilometers. The company who puts the roads in, say it's basically about $1 million per mile, but let's say it's $1 million per kilometer, and we're going to build a 40-kilometer road to account for all twists and turns. So that's $40 million to build a road Canadian. Let's throw in power line for the same amount. However, I've been told power line's not that much. We'll still say it's the same amount. Now we're up to $80 million. Let's put in all of the infrastructure. So we do need a crusher on site. We do need some heavy equipment. We need accommodations, not much, but we need accommodations and other little ancillary buildings. But let's throw those in for another 40 million Canadian, which I think is way too much. But now we're up to 120 million. You mine 2 million pounds of uranium at $70 a pound USD. That's 140 million USD. You do the conversion to Canadian, it's about 180, 190 million Canadian. You've now just paid off your capex plus your operating costs with 2 million pounds of uranium. The rest is all at operating costs. Very quick and easy. To get to remove the overburden, to create a starter pit from the overburden material 25 meters down takes less than 6 months. The guys that we have looking at doing a road for us say that's less than 12 months. Permitting, I've talked to the permitting people. If Key Lake Mill would take our waste rock, our permitting process is cut down in half because a lot of the permitting process is all about remediation and acid rock drainage studies, water, and so forth. But if the mill takes our tailings, our permitting process is cut down in half. That is crazy. So we can fast track this into a possible production scenario at a very low cost. Sorry, I meant to say that earlier because I do think that is very important. None of that is third party confirmed. Okay, that's me doing calculated back of the envelope calculations and using numbers communicated from third parties and other ideas. But it is not those are not official numbers. What they kind of emphasize what we're after, what we're trying to do. So 3 years down the road, I hope that we are in that permitting process for ACKIO. And I hope we've got a road built there.
And one little mini comment, I just run the calculation. So 2 million pounds, if it were to be 1% material, let's say if you can have that would be 90,000 tons of 1% material. That's not a lot of tons. That would be more than payback. So yeah,
it's crazy. Again, these are,
do you have a sense of what footprint that would be? Kind of, I don't know, like how many meters by, it would be nothing, right? 9,000 tons. Yeah. So
that'd be very tiny.
Yeah.
We envision the open pit being pretty shallow as it is, and then a lot of the other mineralization can be accessed through adit or a decline access at the bottom of the pit.
Yeah. Okay, James. We'll speak again. I'm certain of that later this year. But thank you for your time. Excellent presentation. I think this will be very informative, people.
All right. Thanks a lot. Happy to do so again.